Hi everyone! Today I want to give you a detailed introduction to the React useReducer hook. Like useState, it manages local states, but it can do more. Let's look at this example. Here is a user Connie. She might have written a comment or made a video, which you can read for her. Here is increment, and here is decrement. Now, if you use useState, here is the code. At first initial state, it contains two properties. The first is the name and the second is the score. Now in the state management example component, we use useState at first to initialize the state. And the useState returns two elements. The first is state. The second is the setState. It's a function. Then let's look at the JSX, and here are two buttons. The first is increment button, the second is decrement button. And our task is write functions for the two buttons. So let's look at the function. It's very simple. In increment, just call the setState and return the state which you want. The same for the decrement. So it is so simple an example. Let's look at how to convert it to useReducer. At first, import the useReducer. Then we can directly change the useState to useReducer. It returns the two elements the same as useState. The first is state. The second is a function also to set state, but we call here dispatch because it can do much more than set state. And the useReducer takes three arguments. Usually we give it only two. The first is a function. We call it, for example, reducer. And in the reducer, we put all the logic in this function. And the second is initial state. It's the initial value of the state. So let's define the reducer function, which contains all the logic how to deal with the state. The reducer takes two arguments. The first is the state, the current state, and the type is simply the type of initial state. The second argument is action. It actually tells what you want to do and how you want to do it. It can be actually any type, but out of habit, we define it as such as T-action. Let's take a look here. Type T-action is equal to the first property is type, what you want to do. Here increment or decrement, download. Then here is the payload, how you want to do it. We give it a number. For example, add 1 point or subtract 1 point. You can imagine it as cooking. You want to add sugar or reduce sugar, or add salt or reduce salt, and how much. Now let's take a look at the function reducer. So we can now use switch to deal with different action type. Switch action.type. In case of increment, we will just add a point. Here we can just copy the earlier code snip here. And don't forget, change the previous state to state. And the one point, now we can change it to action.payload. It will be more flexible. The same for the decrement. And the plus will change it to minus. And don't forget to give a default. We just do nothing and return the original state. We finished the logic in Reducer. Now we can simply remove the increment and decrement functions. Just remove them. And because we can call the functions in the button dispatch, which returned from useReducer. And how to write it? And we use the arrow function. And in the function, we call the dispatch. And the dispatch take an argument that's exactly the same as the reducer. And it is a type of T action. And it has two properties. One is type, increment, and the second is payload. Here is 1 point. And the same for the decrement button. An arrow function, dispatch, type is decrement, and the payload is also 1 point. Now let's check the result. Refresh, add a point, minus 1 point, minus 1 point, exactly the same. Now let's change the payload to 2 points. Take a look what will happen. Refresh, add 2 point, minus 2 point, minus 2 point. Correct. In this example, we didn't see a lot of advantage of useReducer, but in case of you have more buttons or more complicated logics like multiply or square the root, maybe useReducer is your best friend. Now let's take a look at useImmerReducer. It is a hook from the third-party library immer.js. This hook can let you treat immutable object as mutable object. So why we need this one? Because React requires you treat all the state as an immutable object. Otherwise, unexpected situation will happen. For example, not render. So we need to, in the reducer, use the spread operator to deep copy the state. But if your state is complicated or deep nested, then you need a lot of spread operator, and this will reduce the readability of your code. So now we can use the useImmerReducer to solve this problem. How to do it? At first, install the library npm install immer and useImmer. After that, let's import the useImmerReducer. Then we can change the useReducer to useImmerReducer. They are actually the same. Now, in the reducer, you can treat the state as mutable object. Just change it direct to state.score plus equal to action.payload. So here you don't need to return anything because the state is mutable. But don't forget a break. And it is the same for the decrement. And just do the same thing, copy the code here and convert them plus to minus and break. In the default, the same, just a break, you don't do anything. Now you suddenly simplified your code. Now let's check the result. Refresh, add 2 point, add 2 point, minus 2 point, minus 2 point, correct. Now let's take a look at the initial action, the third argument of useReducer. If you put your mouse on the useImmerReducer or useReducer, they're actually the same. It will pop up to show you the third argument, initial action. It's a function, and it is how to initialize a state. You will feel strange. You have already given the initial state value. Why you need a function to initialize the state? The reason is, in most situations, you don't need it and just skipped it. But in some cases, you need it. For example, here you added some points to Connie, but refreshed the page and the points suddenly became 0. This is definitely not what you want. Let's make a more realistic example. You have a long form. User have to complete the form to order the product. But before he submit, he accidentally clicked the refresh, everything gone, and you lost $1 million order. This is definitely not what you want. How to solve this problem? It is simple. Just save the state in user's browser. Every time immediately after refresh, take a look if there is a state saved locally. If yes, then use this state. Otherwise, use the given initial state. Now let's look at how to write the code. At first, in the reducer function, we use local storage to save the state. We use a local storage.setItem, and we give it a key. The key, we call it simply state, and the value is of course state, but local storage can only accept string, so we will use JSON stringify to convert the state to string so that we can save the state. Now let's go to the useImmerReducer, the third argument. We give it a function called initialAction. Now we can define it here. Const initialAction equal to the arrow function. It takes the state argument. It's actually the second argument of the useImmerReducer. So the type is simply type of initial state. Now in the function, we should at first check if the state existed in the local storage. We define a const called res is equal to local storage.getItem, and we find the key state. Now we should check if the state exists. If res exists, then we should return this object. But take care, the res is a string. We need to convert it to state object, so we use the JSON path to convert it back. If there's no res exists, then we just simply return the initial state. Now let's check the result. Add points, add points, add points, refresh. Cool, it stayed at 6. Now let's upvote again. Refresh. Great, it's still 10. It didn't fall back. Now let's check its local storage. Go to inspect, and here application. We can see the state is saved. And let's download it. And the state kept. Refresh. It's still 6. Okay, this is about the third argument, initialAction. Now let's look at how to use async await with useReducer. The reducer function has a small problem. It's a plain function, so you cannot put await such async function in it. But a lot of tasks you need the async function, like get the data with REST API. But the solution is also simple. You just put the async function outside of the dispatch. I usually wrap the async function and dispatch together and make a new function called wrap dispatch. Let me explain you again with this example. I want to add some sounds when I click the button. Since the function to play sound is an async function, so I can demonstrate you how to do it with useReducer. Now let's, in the state management example, define the wrap dispatch function, which wraps the async function and the dispatch function. Since it is a wrap, it should take at least the same argument as the dispatch. It should be the action. The type, of course, is a T-action. In the function, we define at first the audio object. Const audio is equal to new audio. And then we can use switch to treat a different action type. In case of increment, we can set the audio source as this one. Just let me copy it. And don't forget break. Then, in case of decrement, then we set the audio sound source as this one. Break. And in default case, do nothing, just break. Now we can play the audio. Simply audio.play. But the play is a promise, so we need to add an await before it. However, it will be an error, because the await can only stay in async function. So we need to mark the wrap dispatch as an async function. Now we can call the dispatch function safely. Dispatch, and the argument is simply action. Okay, now the wrap dispatch function logic is finished. The next task is simply change the button function from dispatch to wrap dispatch. And here the same, wrap dispatch. Okay, let's check the result. Increment, increment, decrement, decrement. Okay, this is all about useReducer. Thanks very much for listening and see you next time.